All right, now for the second part of our video, what we want to do is look at some examples of how this actually looks when I'm graphing inequalities. Okay, so it's just the same as graphing a line. For the first part, I can just think of where I need to start, how I get a second point from the slope, and then it changes to inequalities. Okay, so let's just go through this. Where do I start? I start with the y-intercept. So start at -5 on the y-axis. Use my slope of 1/3 to get the next couple points. So 1/3 means go up 1/3. So up 1/3, positive slope, so it's going up from left to right. I get a couple of points in there. Okay, so now here's the part where it becomes an inequality different from a line. I have to look at the inequality symbol. It is just greater than, not or equal to, so I'm going to have a dashed line. So I come in here with a dashed line. And I also have to then look at that symbol and understand that that says greater than. So I want all the y values that are greater than or bigger or more than that line. So all the y values that are bigger are going to be above. So I'm going to shade above the line. Okay, with this second one, still in slope-intercept form. So I look for the y-intercept to start. Put my point at -1. Use my slope of -2. That's just like saying -2/1. So that says go down 2, go over 1. So I'm going to go down 2/1, get a few points in here, a couple more so that I can do this on here without getting too crooked of a line. Okay, now I look at the inequality symbol. It's less than or equal to. So I've got less than or equal. Because of the or equal, that means the solution includes the points on the line, so I'm going to make that a solid line. Okay, it is less than, so I want everything that is below this line. Okay, so I'm counting on you that you have graph paper out and you are doing these with me so that you've got good examples in your notes. Okay, what about this one? This one has standard form. So if you remember what we were doing yesterday, we're going to solve this to get y by itself. First thing I'm going to do is move the x. So I'm going to subtract 5x. That leaves me with -2y is greater than, keeping it in y equals mx plus b. So I'm going to put the x part first. And here's the thing we have to remember, is that when I divide by a -2 here, it's going to flip the inequality symbol. Dividing by a negative flips the symbol, the inequality symbol, in solving inequalities. So I'm going to have y, and then remember we have to divide both these terms by -2. So negative 5 divided by negative 2 becomes positive, and that's my slope. 12 divided by negative 2 becomes negative 6. All right, so just like we did before, start with the y-intercept. So I go to negative 6 on the y-axis. Then I look at my slope. It's going positive, so up 5, to the right 2. Get a couple of points in here. And I'm going to draw the line. So now I look at that inequality symbol. It's just less than. So I'm going to have a dashed line. So I put in my dashed line. And it's less than. So I want to shade everything under. Okay, the other way you can test shading is I pick a point, because obviously this inequality, the line divides the graph into two pieces, right? Over here in the shaded area, that's all the points that make it true. On the other side, where it's not shaded, are all the points that do not make this true. So if I were to take and put this point 0, 0 into my inequality, I would have 5 times 0 minus 2 times 0 is greater than 12. So 5 times 0 is 0. 2 times 0 also 0. So I get 0 is greater than 12. Well, that is obviously not true. That is why this point 0, 0 is on the side that's not shaded. So you can always choose a point to verify your answer. So look at this. What if I have one that's done and I want to go kind of backwards and write the equation of the inequality? So I'm going to do it just like we did with lines. I have my y. I'm going to have the mx plus b. Okay, so as I look at this, my b value is 1, 2, 3, 4, 5, 6, 7. My b value is 7. My slope, I'm going to pick a couple of nice points where the line crosses the grid, and I can see that it's going down 1, so negative, and over 4 to the right. So my slope is going to be negative 1/4. So I have this, and all I have to decide is what does the symbol, the inequality symbol, look like? All the shading is above the line, so I'm going to say greater than. The line is solid, so, or equal to. So my line would be this. Okay, take a look at this. How do we determine which ordered pairs are solutions? If I look at the inequality 2x minus 3y is less than 15, and I want to know which points make it true, so they are part of the solution, or do not make it true, so not part of the solution, I'm going to do exactly what we did in that graph where we tested the point by plugging in the x and y. So if I look at this one, I'm going to plug in 2 for the x value, 5 for the y value, and I'm going to see, is it less than 15? So I'm going to have 4 minus 15 less than 15. So I get negative 11 less than 15. So here's the deal. That is true. So it is this point is part of the solution. Okay, let's look at one more. If I plug in -1 and -7, so I have 2 times -1 minus 3 times -7 less than 15. So I get -2. If I'm taking a -3 times a -7, that's going to be plus 21 less than 15. So I have 19 less than 15. So this is not true. So it's not part of the solution. Okay, if you look at this next one, we're going to plug in just like we have been doing, 3 for the x, minus 3 times -4 for the y, less than 15. Okay, so we've got 6, -3 times -4, positive 12, less than 15. So we have 18 less than 15, not true. So again, not part of the solution. Okay, and you'll see here again why 0, 0 is my favorite tester point, because if I plug that in, I have 2 times 0 minus 3 times 0 less than 15. Well, anything times 0 is 0, so I real quickly end up with 0 is less than 15. That one's easy to test. That is true, so that's part of the solution. All right, so what you need to do is homework 2.7. If you are remote today, you need to get that done right now and upload it to the Google Classroom before 2:30.